Bismillahirrahmanirrahim. This question is October November 21, variant 42, topic electricity, question number 8. A circuit contains two fixed resistors and one light dependent resistor LDR. Power supply is 9.0 volt battery. This is the amount of the power supply. The current in 450 ohm resistor is 0.12. Mean in this region, the amount of current is given 0.012 ampere. State what is meant by electricity. By definition, rate of flow of charge through cross-sectional area of the conductor. This is my observation. Students write this definition with the wrong way. Sometimes students miss this word, rate of flow. This is necessary to mention because flow of charge through the circuit according to unit time. So by definition, I can write mathematically Q by T. So it's necessary to mention about a time. So it's your choice. You can write if you want to write like a flow of charge through the circuit per unit time. So this is necessary to mention about a time, or you can write rate of flow because rate of mean divided by time. So you can write this way. I think it's better. Let me read the B part. The current in LDR is I1. Mean in this region, the amount of current is I1. The current that is available is named as I1. And the current in 800 ohm resistor is I2. So in this region, the current that is available, it's named as I2. According to the rules, parallel and series rule about the current, in series circuit, the current remains same everywhere. But this part of the circuit is parallel. So it means this I2 will be divided into two parts as I1 and as 0.012 ampere in 450 50 ohm resistor. So it means if I give the name as I3, then I can easily divide this current because then mathematically it's very easy for me to write I2 is equal to I3 plus I1. This is the total current according to the circuit. Let imagine this is the total current I2 and this I2 is divided into two regions as I1 and as 0.02 ampere. Now question is that complete the equation that relate the current in 450 ohm resistor to I1 and I2. Mean what is the relation of this current 0.012 ampere with this and with this. So this is very easy. From this equation we can manage this relation very easily as in 450 ohm resistor current is I3. So if I make this object then the answer will be I 2 minus I1. So this is the total amount of the current. This is the relation of 0.12 with this and this. So according to the statement of the question, answer will be here I2 minus I1. Calculate the power dissipated in 850 ohm resistor. Okay, so to find out the power dissipated in this region, I need to find out the voltage drop. But problem is that I don't have a data about that. But this region of the circuit helped me a lot in calculation of the drop of the voltage across 800. Why? The reason because we know that this part of the circuit is parallel. So this parallel part is in series with this circuit, with this resistor. And we know that the battery divides itself in series circuit. So imagine this is a one resistor and this is a second combined resistance of LDR and 450 ohm resistor. So if we find out the drop of the potential in this region, then we can find out the drop of the potential in this region very easily. Why we want to find in this region? Because in this region data is available, 450 ohm resistor is available, current is available. So this is very easy to find out the drop of the potential in this region because whatever the drop between this region it will be the same as LDR. So if somehow I can find out the V here, then I can find out the voltage drop across 800 ohm resistor. So for this purpose, I will use Ohm's law. V is equal to I into R. The amount of the current is given 0.012 and resistor is 450. After multiplication, the answer is 5.4 volt. So it means in this region, the voltage drop will be equal to 5.4 volt, and this voltage drop is in this region as well as in this region. So now out of 9, 5.4 is dropped in this part of the circuit. So remaining voltage, that is equal to 3.6 volt, will be against across 800 ohm resistor. So now it's very easy for me to find out the dissipated power across 800 ohm resistor. So for this purpose, I will use power is equal to V square over R, because V is available, R is available. So this will gives me the answer 3.6 square divided by 800. After calculation, the answer will be 1.6 into 10 raised to power minus 2 watt. In next part of the circuit, the brightness of light that is incident on LDR is increases. Okay, I hope so. You know this relation that in case of LDR, the brightness and the resistance have inverse relation. Mean brightness increases, mean resistance decreases, and vice versa. So here in this part, it's mentioned that brightness of the light that is incident on LDR is increases. Then it mean the resistance across this region will decreases. Mean to say when the light will increases, then R in this region decreases. Okay. So these two resistors are connected with each other parallel. It means when the R of LDR decrease, then overall resistance will be dropped, right? So when overall resistance of this region will drop, then what is the question now? Explain what happened to the potential drop across the 450 ohm resistor. Another thing, the PD and voltage is also directly proportional to each other. PD and resistance are directly proportional to each other. Mean if the value of the resistance is more, then the drop of the potential will also more, and vice versa. So to find out this answer, the situation I have described to you, now let me write the answer for you. So you can write the answer in this way. Brightness increases mean resistance of LDR decreases. So resistance of parallel part of the circuit decreases. It means the PD across 800 ohm resistance increases and the PD across 450 ohm resistor decreases. Why? Because I already explained, because this resistance drop because of increase in brightness. So this region have total resistance less as compared to the previous condition. So it means then voltage drop in this region will definitely less and voltage drop across this region will increase. I hope you will understand this.